All right, good morning, you guys. Just a couple of quick things before I start today. First off, I wanted to say I'm so very, very proud of you guys. You guys are doing absolutely excellent so far, so keep up the good work. Second thing, make sure I am leaving you guys feedback in Desmos. So telling you guys if you did something wrong, please make sure you are looking at that because a couple of you have made the same mistakes the last couple of days and you're not fixing those. So please take a look at that. Otherwise, today we are going to look at our second conic section. So our second conic section is the ellipse. So if you did make that little foldable thing, like I told you to the other day, today would be, right now would be a good time to find that and pull that out. All right, but notice an ellipse is kind of like an oval. So a couple things to take note about the ellipse. Whereas a circle, we had that center point, and then every point around it was the same distance. With an ellipse, that is not true. So this distance right here is not the same as this distance right there. Okay, so circle, all the points on the outside are the same distance away from the center. With an ellipse, that is not true. Okay. All right, so before we get any further, I want you guys, again, if you made that thing, to put this in there. So here's the standard equation for an ellipse. So I'll give you a second to write that down. I need to write it down too. So I'm going to write down the standard equation and all this information. So notice the center is the same exact thing for a circle. So our H is that horizontal displacement and K is that vertical displacement. Again, notice it is the opposite of what we think. Some of you are forgetting the opposite. So opposite of what we think. The horizontal radius. So horizontal radius is exactly as it sounds, is this length right here. That is represented with A. Notice in our equation, though, they put it in as A squared. So kind of like what we did with circles with regular radiuses. Sometimes the horizontal radius is called the major radius or the major axis, you'll sometimes hear. Vertical radius, again, just as you sound, is this length right here. So vertical radius is represented with a B, and again in the equation it is the B squared. Sometimes you'll hear it called the minor radius or the minor axis as well. All right, so the first thing we are going to do today is we are going to graph them. So let's go ahead and do that. I think I'm going to do this one first. So graph the ellipse. So just like what we did with circles, I'm going to find my center first. So notice I have nothing that is attached to that x. Technically there's a 0 though. So that horizontal distance is 0. And then my y distance for the center, remember opposite of what we think. So I'm going to go down -3. So my center is the point 0, -3. And now, next up, I'm going to find my horizontal radius. So remember our horizontal radius was that A value. In our equation, this is the A squared. So if A squared equals 16, That means our horizontal radius, take the square root of that, my horizontal radius is going to be 4. So in terms of my graph, that means I need to be able to go left 4 and right 4. Next thing, my vertical radius. Again, that is represented in the equation b. Remember, this is our b squared. So b squared equals 25, then b has to equal 5. So my horizontal radius we said was 4, so horizontally I'm going 4, which means the vertically then, vertical radius is 5. So I need to go up and down 5. And now, best you can, please connect your dots. I know that's not always the easiest on a computer. Oops. But my ellipse is going to look something like that. All right, let's do another one. Let's do this one right here quick. All right, so my center here, again, I'm looking at these pieces right here. Remember, center is opposite of what we think. So my x value will be positive 3. And my y value will be negative 2. So my center is at the point 3, negative 2. My horizontal radius, so since a squared equals 16, that means my horizontal radius is going to be 4, which again means I need to be able to go left or right 4. My vertical radius, if b squared equals 9, that means b is going to be 3. So my vertical radius is 3, which again means I need to be able to go up and down 3. Connect the dots as best you can. And that's going to look something like that. Perfect. Let's see. Let's see if I give you a graph. Could you give me the equation? Again, one thing that tripped you up the other day was the scale, so make sure you're paying attention to that. So each of these lines is actually going up by half, which means that is negative 1. And we can see that's negative 2. So if I identify my center is the point negative 1, negative 2. Let's go ahead and identify that vertical radius, or horizontal radius I want to do first, so the a value. So this distance right here, so here's 1 and there's 2. So my vertical radius, my a value is 2. Sorry, I keep calling them vertical. It's horizontal radius. I'm going this way. Horizontal radius. Now let's talk about the vertical radius, which is my b value. So vertical radius is our up and down one. So here's 1, 2, 3, 4. So our vertical radius is 4. B value is 4. And now let's plug her in. So we have x minus our h value. So minus negative 1, that's going to give me a positive. All over a squared. So 2 squared is going to give me 4. And then we have y minus our k value. Again, is going to give me a positive. Over b squared. 4 squared is going to give me 16. And that has to equal 1. So again, a couple big things to point out with this formula. We are adding these two things together, and it always equals 1. Always. All right. Last thing then, if I can find it. just like with circles, it's not always in this nice standard form where we can easily identify what the center is and what our radiuses are. So we need to be able to, once again, complete the square and get it into that standard form. So, a couple of things to point out. Again, make sure you want to get your x's together. Make sure your y's are together. Make sure your constant is on the other side. Just like with completing the squares and with circles, you always want to have that leading coefficient be 1. Now, if you remember yesterday when we were doing this with circles, if we had something other than 1 as a leading coefficient, it was for both the x squared and the y squared, and we could easily divide the whole thing by that number. Today, that's not the case. Notice in front of the x squared, I have a 4. In front of the y squared, I have a 1. So if I were to actually do that same thing we did yesterday and divide everything by 4, I'd end up with a leading coefficient of 1/4 in front of the y squared, and that's not going to help me. So today, what we're going to do is we're going to entertain the idea of a GCF. And for right now, I'm going to ignore everything else and just look at the x's. And what I'm going to do is, in order to get that number in front of the x squared to be a 1, I need to take out a GCF of a 4. So I'm going to go ahead and do that. So that would mean that's going to be a 2x. Notice I made some space here just because when I complete the square, I know I'm going to have to add a number. And if we look at this one, the y's, I already have a leading coefficient of 1 here, so I don't need to worry about taking out a GCF at all. Again, I'm going to leave a little bit of space for when I complete the square. All right, so let's go ahead and do it. Remember, the first step is I need to divide the linear term by 2 and then square it. So 2 divided by 2 is going to give me 1. 1 squared is 1. And remember, whatever I do to one side, I also need to do to the other. You need to be very careful, though, because technically this 4 still needs to be distributed back into this. So technically we are adding a 4 to both sides, because once I distribute that back in, 4 times 1 is going to give me 4. So be careful with that. Over here, thankfully, we don't need to worry about that. So my middle term divided by 2 and squared, and I get 2 squared, which is 4. And again, technically there's a 1 out there. So over here, it is just like what we're dividing by 4, or adding 4, sorry. All right, so now let's go ahead and write it as a binomial squared. So remember that number we get, that linear term divided by 2 is the number that we put in here. And let's see, that's going to equal 16. All right, last step. Again, remember in the equation, where did I put it? Somewhere. I don't know where I put that. I just had it. Anyways, remember in the equation that it always has to be set equal to 1. So in order to get everything set equal to 1, I am going to divide everything by this number. So now 4 divided by 16, that's going to give me a 1/4. And 1 divided by 16 is just going to give me 1/16. And 16 divided by 16 is 1. So now we can easily tell that our center is -1, -2, opposite of what we think. Our horizontal radius, that A value, is going to be 2. And our vertical radius is going to be 4. All right, let's do one more like that. again, find the equation of the ellipse in standard form. So first thing I'm going to do, I see everything's jumbled up. So again, I'm going to put my x's by each other. I'm going to put my y's by each other. And I'm going to move the constant to the other side. Next up, remember, we need to have our leading coefficients be 1. So remember this idea of a GCF. So in this case, I need to take out a 4. For the y's, I'm going to have to take out a 9. And I'm going to leave that at the negative 4. I'm not taking anything out of that. All right, so let's go ahead and complete our square then. So middle term divided by 2 and squared. Negative 1 squared is going to give me a positive 1. And technically, remember, I added a positive 4 to this side, so I need to add a positive 4 to that side. If I do the same thing over here, so divide that middle term by 2 and square it, I'm going to get negative 2 squared, which is going to be a positive 4. And again, technically, I added a 36 to both sides. So here I just wrote it as that binomial squared. All right, last step, I need to divide everything by 36. So I can get this to be equal to a 1. So 4 divided by 36 is going to be 1/9. 9 over 36 is going to be 1/4. And 36 divided by 36 is just 1. So now my center is positive 1, positive 2. I have a horizontal radius of 3 and a vertical radius of 2. Beautiful.